Sathyabama Institute of Science and Technology.
Hello everyone, this is Dr. T. Judgi, Associate Professor, Department of Computer Science and Engineering, Sathyabama Institute of Science and Technology. So in this video, we are going to discuss about breadth first search in graph traversal. So this is my agenda. So we'll see what is breadth first search, an algorithm for BFS. How does the BFS algorithm work? We'll see with an example graph. Then we'll discuss about advantages and disadvantages of BFS. Finally, we'll discuss about an application of BFS. So before getting into the concept of breadth first search, first we'll see about the graph traversal. So here traversal means visiting or accessing the element in data structure. Graph traversal is all about the process of visiting each and every vertex in the graph. Why do we need graph traversal? So we know that a graph may contain a cycle. So we may come to the same vertex again. So with the graph traversal, we can visit all the vertices in the graph without getting into the looping path. So what is looping path? This will avoid to come to the same vertex again. So traversals are classified into two categories. The first one is breadth first search, that is BFS. Second one is depth first search, that is DFS. First, we will look into the concept of breadth first search and how it can be applied to the graph effectively. So here breadth first search is a graph traversal algorithm, so in which we can visit all the vertices in level by level manner. It starts at any specified vertex and visit all its neighbors before moving on to the next level in graph. So BFS is commonly used in algorithms for path finding, connected components and shortest path problems in graph. So to avoid processing a node more than once, we can categorize the nodes as visited and not visited. So here BFS uses queue data structure for traversal. What is queue data structure? So it follows the principle of first in, first out. That is, the element that you inserted first will be removed first. So this is about the breadth first search in graph traversal. So this is an algorithm for the BFS. So here initially we have to enqueue the starting node into the queue and then we have to mark it as visited. Then we have to dequeue a node from the queue and we have to visit it. That is, we have to print its value. So for each unvisited neighbor of the dequeued node, we have to enqueue the neighbor node into the queue, then we have to mark it as visited. So these steps will be repeatedly have to do until the queue is empty. So this is an algorithm for the BFS, and this algorithm ensures that each and every vertices are visited in the breadth first manner. So next we'll see how does this BFS algorithm work within a simple graph. So here we can start from any vertex and we have to traverse all the nodes in the particular level before moving to the next level. So this is an example graph. So here circle represent vertices. So there are 5 vertices are there, 0, 1, 2, 3 and 4, and line represent edges. So there are 6 lines are there. So initially there are 2 arrays we are going to take. So initially both are considered as empty. One is for queue and another one is for visited. So as I said, we have to initially we have to enqueue the starting vertex. Since it is a graph, we can consider any node as the source vertex. So here I am going to consider 0 as the source vertex, and from here I am going to start traversing. So now here we have to insert the source vertex, that is 0, into the queue and mark it as visited. Then we have to remove the vertex 0 from the front of the queue. Then we are going to visit the unvisited neighbors. That is, for 0, 1 and 2 are unvisited neighbors. So remove vertex 0 from the front of the queue and then we have to visit the unvisited neighbors. Then we have to insert into the queue. Then we have to remove the next element, next node from the front of the queue, that is 1, we have to remove it, and we have to visit the unvisited neighbors for the vertex 1, that is 3, we have to visit it, then we have to enqueue into the queue. Then next vertex 2, we have to remove it from the queue and we have to visit the unvisited neighbors of 2, then we have to enqueue them into the queue. Then we have to remove the node 3 from the front of the queue and visit the unvisited neighbors, and we have to enqueue them into the queue. As we can see, here all the vertices are visited. Then we have to move to the next element into the queue. So here 4 are in front of the queue, then we have to remove it. So here we can remove the node 4 from the front of the queue and visit the unvisited neighbors, and then we can push into the queue. So this is processed not till the queue is empty. So this is an working principle of BFS algorithm. So this is an we can consider this is a example 2. So here you can start from any vertex. I am going to for example, if we start from the vertex 1, so then level by level it will be traversed. For example, 1, then the next level 2, 7 will be traversed. Then in the next level 3, 6, 8, 10 will be visited and traversed. Then it will be traversed for in the next level 4, 5, 9. So like that it will be traversed in the breadth-first manner. So next we will see about the advantages and disadvantages of BFS. So this is easily programmable and it is simple to implement. There is more than one solution are there. When then we can use the BFS to choose the minimal one, and it is very efficient for finding the shortest path. Here the main disadvantage is it require more memory, because for each and every level we have to save it then to get the next level. So then we'll see the application of BFS. So BFS we can use for finding the shortest path between the two vertices, and we can use BFS to check whether the cycle is present in the graph or not. Then in peer-to-peer networks we can use BFS to find all the neighbors nodes. Then for broadcasting in network, so all the broadcasted packets will use BFS to reach all the nodes. Then in garbage collection, so it will used to BFS used to copy the garbage data. Then for path finding also between the vertices, we are using BFS. Then for GPS navigation system, so it is BFS is used to find the all the neighbor locations. Then for connected components, so whether it's the components are connected or not, now we can use BFS algorithm. Thank you.